All right, so yesterday we found the inverse of this quotient function, 5 minus x over 3x plus 2. All right, so again, just be careful when you cross multiply. Make sure all your signs are in order, right? Your negatives and positives. And we found the inverse, which looks similar, okay? But you can tell the difference between the two. So what we're going to do today is I'm going to show you, that the proof that they are in fact inverse. All right, so give me 1 second. I'm going to copy this down on the other page, and then I'll show you. So we have f of x. Our original function was 5 over x. And our inverse function all right, so I'm only going to show you one way just for time's sake, since we only have half an hour. So I'm going to do f of negative 1 of x. Again, we're trying to make sure that these two functions are in fact inverse, right? Just in case that we made a mistake calculating. Wait, did I write that right? No, I didn't. This is plus 1. Five minus x. 3x plus 2. 5 minus 2x. 3x plus 1. Okay. So I'm going to treat this like we did any composite function. So I'm going to rewrite this with my 5 minus 2x over 3x plus 1 on the inside. So here's where we got to be careful. There's going to be a lot of fractions going on. So I'm taking this whole fraction and I'm plugging it into this x and to that x. All right. So we're gonna get a lot of room here. So in the numerator, we're gonna have 5 minus this whole thing. 5 minus 2x over 3x plus 1. And then the denominator, I'm going to have 3 times my phrase, my expression, 5 minus 2x over 3x plus 1 plus 2. Now remember, I want to boil this down so that our final answer is just x, right? I want this to equal x. So where do I begin? Okay, so when we deal with this, when we have a fraction within fractions, I want a common denominator for both. Okay, so what I'm going to do first is I'm just going to simplify everything so we get rid of these parentheses. I'm going to put 5 over 1, because this isn't a fraction yet, but we're going to have to make it a fraction. I'm going to put minus 5 minus 2x over 3x plus 1. Okay, so all I did so far, I just removed the parentheses and I made that a fraction. Now here, this 3 gets distributed, but it only gets distributed to your numerator, right? Because this is 3 over 1. So here, we're going to have 15 minus 6x over our original 3x plus 1, and then plus 2 over 1. All right, well, here our denominators are the same, so that's a good start. So our common denominator is going to be 3x plus 1. So here I don't have to do anything to this. Here I'm going to multiply top and bottom by 3x plus 1. I'm going to do the same thing to this too. X plus 1. Okay, so I'm going to multiply top and bottom there. All right, so for now, I'm not touching this or that because they already have a denominator, and that's the denominator we're looking for. So up here, again, we're going to distribute this 5. So you're going to have 15x plus 5 over 3x plus 1, right? That's our common denominator. Minus, again, I'm not touching this, so I'm just going to leave it 5 minus 2x over 3x plus 1. All right, so that's good because now we have a common denominator and we'll be able to simplify that. Down here, this first term I don't touch. I have 15 minus 6x over 3x plus 1. Now again here, I'm going to distribute this 2. So I have 6x plus 2 over 3x plus 1. All right. So for now, I'm still dealing with just the numerator and just the denominator. I'm going to combine like terms. Be very careful with this. Remember, when we add and subtract fractions, the denominator stays the same. So for both of these, I'm going to have a denominator of 3x plus 1. Combining like terms in both my numerators, I have a 15x minus negative 2x. That's going to give us 17x. I have a 5 minus 5. That's gone. So here I just have, let me put this a little nicer, 17x. Okay, so again, the 15x minus negative 2x, that becomes plus. So we have a 17x. Now here, again, I'm going to combine like terms, again, just for my numerator, because the denominator is going to stay the same. I have 15 plus 2. That's 17. I have negative 6x plus 6x. They eliminate. Now I have a fraction over a fraction. Going back to Algebra 1 geometry, when we divide with fractions, I'm going to do keep, change, flip. All right, so this is going way back. So we're going to keep the numerator as it is. 17x over 3x plus 1. We change division to multiplication, and we take the reciprocal, we flip the bottom fraction. All right, so we kept the numerator, 17x over 3x plus 1. Let me make that look that's a little sloppy. Okay, change division to multiplication, flip the bottom. Now we have 3x plus 1 times 17. Now that we're multiplying two fractions, things become really simple. I have a 3x plus 1 in the denominator there, and a 3x plus 1 in the numerator there. And they eliminate each other, right? If you had a 2 over 2, they would both be gone. So this becomes 17x over 17, and what do you know? The 17s eliminate, and we're left with x. All right, so I'll bring that down so you can see everything that happened. All right, so it's you know, it looks like a lot of work, but as long as you're careful, all right, it's pretty simple. All we're doing is, you know, combining like terms, common denominator, and then that little keep, change, flip at the end. Any questions there? Okay, so with that being done, let us take a look at the homework. Okay, so your homework was find the inverse of f of x equals 7 minus 3x over x minus 2. If you were having issues uploading things, I know my other class was too, you can email me your work. Right, just take a picture of it and send it to jmurray@ppsstaff.org. All right, so let's go over this. So our steps, first we change the f of x to a y. Right, they're both subtracting. Let me just double check. Yep, okay. Right, then we swap. So I have x equals 7 minus 3y over y minus 2. Okay, now that we have it like this, we want to start getting the y's isolated. So we cross multiply. So we have x times y minus 2 equals, I'll put the 1 there for now, 1 times 7 minus 3y. Okay, we don't need that. So if you didn't put that, that's fine. We have to distribute the x, xy minus 2x equals 7 minus 3y. Right, so up to that point, that's pretty much the steps you got to follow. Now from this point, you may take a different approach, but again, as long as you end up with this final answer, the same final answer, you're good. So what I'm going to do is I'm going to add 3y to both sides because I don't like dealing with negatives. Okay, now be careful. I put this underneath here, but I can't combine this with anything because remember, our variables have to match up exactly. Right? If this was 3x, then I can combine the 2x and 3x, but this is 3y. Okay, here I have a y, but it's also xy. Right? I don't have an x here, so I can't combine anything over here. So we're just going to write it out, xy minus 2x plus 3y. Right? We can't combine any like terms, right? We have to leave it like that. On the right side, I'm just left with 7. All right, well, I'm almost there. I got the y's on the same side, but I have this 2x there, negative 2x. So I'm going to add 2x to both sides. And just like before, okay, this is a 7 with no variable, a constant term, and this is 2x. So I won't be able to combine anything. So xy plus 3y equals 7 plus 2x. You can have 2x plus 7 there too. It doesn't matter the order because it's addition. All right. Order only matters when we're subtracting. All right, almost there. We have our y's on one side, but there's 2 of them. So remember, we can factor that out. What do I have left over when I factor out a y? I have an x plus 3. I haven't touched the left side yet. 7 plus 2x. The y is by itself. We're multiplying y by all of that. So I'm going to divide. All right. So I'm kind of skipping a step, but we can say that the inverse is going to be 7 plus 2x over x plus 3. So again, we're using kind of the same numbers, right? But you can obviously see some things changed. 7 minus 3x, 7 plus 2x, x minus 2, x plus 3. All right, so that would have been your final answer. Any questions?
I made a dumb mistake. Instead of the 3y, I didn't put the 3 in there, so I just put y by accident.
For this one?
Yeah. No,
Okay.
like in the beginning.
Oh, I got it. So this was just 7 minus y you had up there? Okay. Well, I'll take a look at it. As long as you stayed with the same thing, you know, maybe I'll minus a point just because you messed that up. But as long as the steps were correct, you're good. Thank you for letting me know.
I got that answer, I didn't put 7x plus 2. I put 2x plus 7.
That's okay. That's fine. Yeah, because instead of here, right, you had 2x plus 7. As long as it stayed 2x plus 7 the whole time, that's okay.
All right.
Right, yeah, like I said, as long as you're adding, okay, those can switch. But if that was a subtraction sign, if this was 7 minus 2x, it would have to be 7 minus 2x. Or, I'll just put it up here. So if you had 7 minus 2x, the other form would have to be negative 2x plus 7. But as long as it's addition, you can flop them. That's okay. Good question. Good question. Any other issues or concerns? All right, so it was a light day for us today. Like I said, we're pretty much done with our first chapter. All right, so no homework tonight. Depending on when I get the quiz done, it'll either be up later tonight or tomorrow. And that's all you have to worry about until Tuesday. All right, so you got some time.